Today in distributed system, we will be discussing about system models. Myself Shiva Tyagi, Assistant Professor in CSC Department of AKGEC. In system models, we will actually be dealing with the introduction part, then some architectural models, fundamental models, and lastly the summary. So, let us discuss the introduction part. The common properties and the design issues are in the form of descriptive models for distributed system. That means we will be dealing with the common properties, the different design issues. They are basically in the form of descriptive models in distributed system. As far as these fundamental models are concerned, they are basically introduced that helps to reveal the key problems. What are the key problems that the designer is actually facing while they are designing the distributed system? We will be dealing in terms of the fundamental models. What is actually the purpose of these very models? The purpose of these models is to specify the design issues, the difficulties, what are the different difficulties we are facing, the threats that must be resolved to develop the distributed system. So, what is actually the purpose of these very models is to specify the design issues, what are the different design issues we are having, what are the different type of difficulties we are facing, the threats, and that need to be properly resolved. Now, what are the difficulties and threats for the distributed system? Okay, there are different type of difficulties that we face and different type of threats for a particular distributed system. What are they? Initially is the widely varying modes of use. We are having different modes of use. So, this is the first difficulties that we may have. Second is the wide range of system environment. Okay, we are having different system environments in distributed system. Next is the internal problems. What are the internal problems? First is the non-synchronized clocks. As we are already aware, we are having this non-synchronized clock in distributed system. So, this is basically the internal problems that we are having. Next is the conflicting data updates. Okay, as we are updating the data, so there may be type of confliction, which is again another internal problem in distributed system. Next is there is many modes of hardware and software failure involving the individual components of a system. We are having different modes, we are having more than one modes of hardware and software failure, which basically involves the individual components of the system. Now, let us start with the basics of the model. Initially, as I told you, is the architectural model. What do we understand by this? It basically defines the way in which the components of the system interact with one another. See, as it is very clear from the word itself only. It is something which basically defines or describes the architecture of the system. Okay, how the components of the system are basically interacting with one another. The way in which they are mapped onto an underlying network of computers. Okay. Next is the fundamental model. This particular model provides the abstract view of just those characteristics of the distributed system that affects their dependability characteristics. The fundamental model. Okay. It is going to describe the abstract view only of the characteristics of the complete distributed system. So, this is the basics of the model. Now, architectural model. An architectural model of a distributed system first simplifies and abstracts the functions of the individual components of the distributed system, and then it is going to consider the placement of the components, how we are going to place those very components across a particular network of computers. Secondly is the interrelationship between the components. If we are having different components, so what is basically the relationship among the different components that we are having in the distributed system. Now, we will be dealing with the software layer, the system architecture, then variations on the client server model, the interfaces and the objects, and design requirements for the distributed architectures. So, what is actually software layer? What do we understand by the software layer? It basically referred to structuring of software as layers or modules in a single computer. As it is again very much clear from the word itself only, it is basically the structuring of software, layers of software. Okay, software as a layer or modules we can say in a single computer. So, the services which are basically offered, they are requested between different processes and they are located in the same or different computers in the distributed system. So, this process and the services view, they can be expressed in terms of the service layers. So this is basically the architecture which shows the software and the hardware service layers in distributed system. We are having at the topmost layer the different applications and the services. Then there is a middleware between the operating system that will be having and the application services, and at the lower level we have the computer and the network hardwares. So system architecture. What is system architecture? The principal architectural models on which the distribution responsibilities are based. Architecture of the system. So this is basically the architecture on which the distribution responsibilities are based. First is the client server model, then comes is the services that is provided by like multiple servers, more than one servers. Third is proxy servers and cache, and lastly a peer process. So this is basically the architecture that represents the client invoke individual servers. As you can see, there are different like the process and the computers, and we are having different clients which is invoking this particular server, and the server is responding to that particular client. So in this particular case, the clients invoke this individual server, as you can see here. Now, as in this case, you can see this is basically architecture that shows that there is a service that is provided by multiple servers. See, we are having multiple servers and we are having more than one server. So the service is basically provided to a particular client by more than one servers. Now, this is a web proxy server. We are having different clients. This is a web server and there is a proxy server between this particular client and the web server. So this basically represents the web proxy server. Now, this is basically a distributed application which is based on a peer process. We are having different peer process, and this application is based on that particular peer process. We are having the application, there is a coordination code and they are basically connected. So this application is based on these are different peer processes. Now, let's discuss about the variation on the client server model. What is mobile code, what is mobile agent, what are network computers, then what is thin client, mobile devices and spontaneous networking, and lastly X11 window system. So what is actually mobile code? What do we understand by this mobile code? These are applets. Applets are well known and widely used examples of mobile code. Fine. The users running a particular browser, they select a link to an applet whose code is basically stored on that particular web server, and as far as this code is concerned, this code is downloaded and it runs. So running the downloaded code locally gives the advantages that there is no delay. Fine. And we are going to consider an application which basically requires that users should be kept updated with the changes as they occur at the server. This is basically achieved only by initiated by the client called the push model. And as far as this examples are concerned, we can take like the examples of the stockbrokers and the cricket update. So they are basically the examples of the mobile code. So what are basically web applets? See, we can see there is a client. This client requests results in the downloading of a particular applet code. This is basically the client, okay, and this is a web server. This particular client is requesting this particular result in the downloading of this particular this applet code. Fine. And in the second case, you can see that there is a client which interacts with this particular applet. So these are web applets. Now, what is actually mobile agent? As far as mobile agent is concerned, this is basically the running program, okay. In program, we will definitely be having some code and the data. So this program basically consists of some code and the data, which basically travels from one computer to another. This particular code and the data, they travels from one system to another system. They carries out a particular task on someone's behalf for collecting the information, okay. They are going to collect the information and returning with a particular result. Fine. Then mobile agents might be used, as far as this mobile agents they are concerned, they might be used to install and maintain the software. Okay, we can install and maintain the particular software, which are one of the most important tasks we can say. Then we can compare the prices. If we want to compare the prices of different products, so definitely we can use this. Okay, and they are going to perform a series of different database operations if you are interested in performing like different series of database operations. Now, What is network computer? The network computer downloads its operating system and any application software that is needed by the user from the remote file server. That means computer on a particular network. And as far as this application is concerned, this application runs locally, but the files, they are maintained by the particular remote file server, we can say. So all the data and the code that we are having, that is basically stored on a particular remote location, and that's why the user basically migrate from one network computer to another network. Now what are thin clients? This thin client basically refers to the software layer. Okay, so this is the layer of the software, we can say, that supports the window based user interface on the computer that is local to the user while executing the application program on the remote area. This is basically the architecture of the thin clients and the computer server. There is a thin client, we are having the network computer or PC, we can say, and there is basically the network between this thin client and the application process. Okay, this is the compute server, we can say. Now let's discuss about mobile devices and spontaneous networking. Hardware components moves between different locations. They carry software components with them, service discovery, and lastly location management. What are actually interfaces and objects? What is object and what is interface? These are the set of functions which is available for invocation in a process. They are specified by one or more interface definition. Well, with the C++ and Java, like the distributed objects, as you all know, they are basically created. And objects can be encapsulated in server process, and in reference to them they are passed to another process so that the methods that will be dealing can be accessed by any remote location. Now this is one of the most important topic that we'll be dealing with, design requirements for distributed architecture. If we want to design a particular architecture, a distributed architecture, what are the different design requirements that we'll be dealing with? We are having different performance issues, then the use of caching and the replication, and lastly the dependability issues. So definitely, as far as the requirements are concerned, what are the different design requirements? Okay, so this is something which plays a very important role in your distributed architecture. Let's discuss about the performance issues. What is the performance of the system? Okay, how fast the particular system is responding. So let's discuss about responsiveness. What is responsiveness? Users of interactive application requires a fast and consistent response to interaction. Okay, we actually want whatever query we have, that query should be responded quite early. So how the particular system is responding, how fast the system is responding. So when a remote server is invoked, the speed of the responses depend not only on the load and performance of the server, but the network delay also. That means if there is any type of delay, that actually does not depend only on the load and the performance. That also depends upon the delay, if there is any type of delay in the network. Now, to achieve good response time, we actually want to achieve good response time. Okay, how fast the system is responding, how much time that particular system is taking to respond to a particular query. So that is important thing. So the system must composed of few layers. The data quantity should be small. As far as this example are concerned, like less graphics, locally cached pages. Now throughput. What is the throughput of the system? What is throughput? It is basically the rate at which computational work is done. How the at what speed the computational work is done, and it is basically affected by the processing speed of the client and the server. Then the rate at which the data is basically transferred, the data transfer rate, we can say. Now balancing computer loads. In some cases we can say that load balancing may involve moving different partially completed work as the loads on the host changes. Example are the Java applets. Now what is the quality of service, QoS? This again plays an important role. This basically means the ability to meet the deadlines of users' need. What is the quality of service that is provided to your users, whosoever will be using the system. Now there are many like non-functional properties of the system which basically affects the quality of the service. These are all known functional properties. They again plays a very important role. How reliable a particular system is. We always want that a system should be reliable. Reliability, okay, probability of failure free operation, Then security, of course, the system that we'll be dealing with should be secure enough, okay, as far as the different threats and all are concerned. So the system should be quite secure enough. How fast the system is responding, what is the performance of the system, we have already gone through this, how the system is responding, okay, how fast the system is responding, what is the throughput of the system, and there is redefined by timeline guarantee. So these are basically different type of non-functional properties which plays a very important role, and they are the one which basically affects the QoS, which is called as the quality of service. Now the use of caching and replication, the design of the system that overcome them by the use of the data applications and caching, how the different cached copies of the resources are kept updated, how we can update the cached copies of the particular resource that we are having. Web caching protocol we are having. Now both the web browser and the proxy server cache their responses to different client restaurant. Fine. And lastly is the cache consistency protocol. Now this is again a very, very important issue, which is a dependability issue. What do we understand by this dependability? The dependability of computer system as correctness, security and fault tolerance. Okay, it is basically described in the form of computer system as a form of correctness, we can say, how secure the particular system is, how correct the particular system is, and in terms of the fault tolerance. Now what is fault tolerance? It is reliability is achieved through redundancy, the provision of multiple resources. We always want that the system should be fault tolerant. How much tolerant the particular system is. If there is any type of issue in the system, the system will be able to recover from that particular type of failure. So how tolerant that particular system is. Security is again one of the most important feature. The architectural impact of the requirements for the security concerns the need to locate different sensitive data, okay, the important data and the data that actually we want to make secure, that the data that we want to keep at a particular specific location, that is important thing, the sensitive data, and the other resources only on computers that can be effectively secured against different attacks. See, as the data is basically on the network, so how secure that particular data is. Okay, if there is any particular type of attack, if there is any particular type of threat, so what is actually the aim, that we are going to secure a particular data from a threat. What is a different type of mechanism? So we always want that a particular system should be quite secure enough. Now comes to the fundamental model that is based on the fundamental properties. It is very much clear from the word itself only, the model which is based on the fundamental properties, which allows us to be more specific about the characteristics of the system, the failure and the security risk. So a model has to address these very three questions. As you can see, what is the first one? What are the main entities in the system? Okay, what are the main entities in a particular system? How do they interact? Okay, the different entities that we are having in the system, how the different entities are interacting in the system. What are the characteristics that is going to affect their individual and this the collective behavior of the particular system. So the particular system model, they has to address these particular different questions, and it is very much clear from the word itself only, the model which is based on the fundamental properties. Now interaction model, performance of the communication channel, then the computer clocks and the timing events, and last is the two variants of the interaction model. Now let's discuss about the performance of the communication channel. Communication performance is often a limiting characteristics. The delay between the sending of the message by one process and its received by another is referred to as latency. This is one of the most important term, we can say latency. What is latency? See, at what time we are sending the message and what time the another process is basically receiving that message. So the delay between the sending of that particular message by a particular process and at what time that particular message is received by another process, this is what is called as the latency. Second is the bandwidth, third is the jitter. Now what is jitter? This is basically the variation in the time that is taken to deliver a series of messages. Okay, there is a variation in a particular time that is actually taken to deliver a particular series. If you are having a different series of message, so this is basically the variation in the time which is taken to deliver a series of the message. So this is basically the performance of the communication channel. Okay, in a particular system we can say we are having different process, so there is basically a type of communication channel between different processes. So based on what we are going to compare the performance, at what time we are sending the message and at what time we are receiving the message, what is the delay between the sending of the message and the receiving of a particular message, and this jitter, this is the variation in the time which is taken to deliver a particular series of messages. Now computer clocks and the timing events, it is impossible to maintain a single global notion of time. There are several approaches to correcting the times on the computer clocks. Like for example, we can say GPS. Now there are two variants of the interaction model. First is the synchronous distributed system, another is the asynchronous distributed system. Now what is synchronous distributed system? The time to execute each step for a particular process has known lower and the upper bounds. Okay, and each particular message that is transmitted over the particular channel, the medium that will be using, is received within the known bounded time. Okay, there is a known bounded time and the message which is basically transmitted over the particular channel. Okay, there is a process which is sending the message and one which is receiving the message. So obviously there is a particular type of channel through which the message is basically sent. So each particular message that is transmitted over a particular channel, that is received within this known bounded time. Now each process has a local clock which drifts, whose drift rate from real time has a known bound. We are already aware of this very fact that if we are having the process, every process has a local clock, and this particular local clock is having a different like a drift rate from the real time that has the known bounds. Now if we talk about this asynchronous distributed system, we have no bound on the process execution time, execution speed. There is no bound on the process execution speed. Now there is no bound on the message transmission delay. In asynchronous distributed system, there is no bounding of the message and the delay in the transmission delay, whatever is the delay in transmitting a particular message. Again, there is no bound on the clock drift rate. There is no bounding. So there is no bound on process execution speed, on the message, that is like the delays in the particular message that we are transmitting, and again there is no bound on the clock drift rate. So this is basically, you can say, a type of difference between the synchronous system and we are having and the asynchronous system that we will be dealing with in terms of the distributed system. So these are two variants of the interaction model. Now failure model, we are having different failure model: omission failure, arbitrary failures, failure detection, the mechanism how we can detect if there is a particular type of failure if it is occurring in a particular system. What is the mechanism that we will be using for detecting a particular type of failure? Impossibility of reaching any agreement in the process in the presence of a particular failure. How we can mask a particular failure? Reliability to one-to-one communication. Okay, if there is one-to-one communication between different process, how reliable that particular system is. Okay, as I told you earlier also, that reliability is something which is very, very important, and we always want the system to be a reliable system. Okay, what is the probability of failure free operation of a particular system? So these are, again, this is something which basically describes the non-functional properties. Okay, this is basically something which specifies the non-functional properties, and that comes under your the functional model that we have discussed. So we always want the particular system to be a reliable system, a secure system, and if a type of failure is occurring into the system, how we can detect that particular type of failure, and what are the different mechanisms with the help of which we will be able to recover if a particular type of failure is occurring into a system. Now security model, the security again plays a very, very important role, and we always want that the particular model should be secure enough in terms of the threats that we will be dealing with, the type of enemy who may harm the data in somewhat or the another way, then protecting the objects, which is of more concern, how with what all mechanism do we have actually with the help of which we are supposed to protect the different objects. Now securing the processes and the interaction, as it is, we are very much clear that we are having different processes, and there is different there is actually the interaction between the different processes. So how secure that particular communication is, how secure that particular transaction is, that is again plays an important role. The enemy, the mechanism, defeating security threats, what are the different threats to a particular distributed system. Then comes the other possible threats from the enemy, if there is any other type of threats from a particular enemy, the uses of security models. So for all these very issues, we actually need these security models. That means we always want that the system should be secure enough. Now lastly, the summary. Most distributed systems, they are arranged according to one of the variety of the architectural models that we have discussed so far. The fundamental models, which basically describes the fundamental issues, like the non-functional properties, interactions, the failure, the security, that identifies the common characteristics of the basic components from which distributed systems are basically constructed. So how we are going to, like if we are talking about architecture, how the architecture is basically designed, the fundamental basically deals with the fundamental properties of the system. So this is basically the summary that we have studied today. Thank you so much.